Okay, we're on page 5 of our review sheet. These problems really working with our Pythagorean theorem, which we remember as a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So we got number 13. If one side of a right triangle is 12 and its hypotenuse is 15, find the length of the missing side. I like to draw a little picture here. One side is 12, the hypotenuse is 15, which means one of our legs is our unknown. So using our a squared plus b squared equals c squared, we're going to have x squared plus 12 squared equals 15 squared. So x squared plus 144 equals 225. Subtract 144 from both sides. And we get x squared is equal to 81. Take the square root of both sides, and x is equal to 9. So the other leg is 9. And 14, what is the length of the diagonal of a 10 centimeter by 15 centimeter rectangle? So we're talking about a rectangle that's 10 centimeters by 15 centimeters. And we want to know the length of its diagonal. So from one corner to one corner on the inside. If you notice, right, rectangles have 90-degree angles. We've created a right triangle. We've created a right triangle in which our hypotenuse is the unknown. So we'll do 10 squared plus 15 squared equals x squared. So 100 plus 225 equals x squared. We've got 325 equals x squared. We'll take the square root of both sides. I'm noticing I didn't leave you any directions for how to leave your problem. I'm going to say let's leave it in simplest radical form. So the largest perfect square factor of 325 is 25, which is 25 times 13, which makes it 5 rad 13. So the diagonal is 5 rad 13. Then we have 15. An isosceles triangle has congruent sides of 20 centimeters. The base is 10 centimeters. What is the area of the triangle? Now we might think, oh, easy triangle problem. Area equals 1/2 base times height. But as we go to see our diagram, we don't know the height. We know the side lengths. We know the base. We don't know that height. Now, we have to realize in the diagram, right, the height really kind of splits into two right triangles. So we can use the Pythagorean theorem to figure out the height, our x, which would be one of the legs of our triangle. The hypotenuse would be 20, right? So right now, so far, we know we've got a leg of x, a hypotenuse of 20. The other leg we have to realize is along the base here. But it's not 10. It's going to be half of 10, which is 5. So we'll have 5 squared plus x squared equals 20 squared. So 25 plus x squared equals 400. Okay. Subtract 25 from both sides. And x squared is equal to 375. And let's take the square root of both sides, and let's say we're going to round to the nearest tenth. So we round to the nearest tenth. We have 19.364. That's going to be 19.4 centimeters. Okay, and I'm going to make myself a little note here that now we figured out that that's our height. So we know that's 19.4 there. So we can go and find our area, 1/2 our base. Our base is the full base, 10, times our height, 19.4. So 1/2 times 10 times 19.4 is going to give us an area of 97 centimeters squared. Really cool problem. I like that problem a lot. Working on page 6 of the review sheet, looking at some surface area and volumes. Determine the surface area and volume of the following solid, round to the nearest hole. So here we have a cone. Let's start with the surface area of our cone, surface area formula. And again, using my reference sheet, using that outline, I've got pi r squared plus pi r L. 5 is our radius. L is our lateral side length. 12 is referring to the height of our cone, that internal height that's perpendicular to the radius, to the base. 13 is the L, the lateral side length. So we'll substitute in pi times 5 squared plus pi times 5 times 13. So that's going to be 25 pi. We'll do our multiplication here. 5 times 13 is 65. 65 pi. Combine our like terms is going to be 90 pi. We're asked to round to the nearest whole. 90 times pi. 282.7, so 283 centimeters squared. 283 centimeters squared. Now, our volume of our cone, if you remember we did that great video for volume of a cone, is 1/3 pi r squared h, or you could do pi r squared h divide by 3. The radius is the same, it's still 5, but no, we're using that height, that internal measurement for volume. Volume, the height is internal. Okay, so we've got 1/3 pi times 5 squared times 12. So that's 1/3 pi times 25 times 12. So that's going to be 1/3 pi times 300. Okay, now I might reorder my commutative property. 1/3 times 300 times pi. 1/3 of 300 is 100. So our volume is 100 pi. Multiplied by pi, round to the nearest whole. 314.159. So that's going to be 314 centimeters cubed. Volume is cubic centimeters. All right, on to number 17. The height of a Diet Pepsi can is about 4.75 inches, and the radius of the can is about 1.3 inches. The new Diet Coke cans have a height of about 5.25 inches and a radius of 1.25 inches, so a little taller and a little slimmer. Determine the surface area of both cans, round to the nearest hundredth. So I want to separate my work. Pepsi versus Coke, okay? And we're talking about the surface area. It's a cylinder, so surface area of our cylinder is 2 pi r squared plus 2 pi r h. Okay. Radius of our Pepsi can was 1.3. And the height was 4.75. So order of operations, I'm going to do that exponent. We're rounding to the nearest hundredth. Okay, that's 1.69. We'll do our multiplication here. 2 times 1.3 times 4.75 gives us 12.35 pi. 1.69 times 2, 3.38 pi plus 12.35 pi. We can combine those like terms. 15.73 pi. And we'll multiply and round to the nearest hundredth. 49.42 inches squared. So there's our surface area for the Pepsi can, the Diet Pepsi can. Now let's find the surface area for our Diet Coke can. Same formula. but different dimensions. Okay, this time the radius is 1.25 inches and the height 5.25. 1.25 squared, 1.5625, so 1.56. Do our multiplication, 2 times 1.25 times 5.25, 13.13 pi. 2 times 1.56, 3.12 pi plus 13.13 pi. Add up those like terms. You get 16.25 pi. Now we'll multiply and round to the nearest hundredth. 51.05 inches squared. Okay, so we can see the Coke can has a little bit more surface area than the Pepsi can, so requires more material. Notice if you rounded a little differently than I did, meaning maybe you left things to the thousandths for a while or you rounded a little earlier than I did, it's possible our answers could be off by just a little bit in terms of the hundredths place. That's okay so long as I can follow your work there. Okay, so B, the aluminum used to make the cans cost $0.03 or 3 cents per square inch. Which can is cheaper to make and by how much? Well, it stands to reason that the Pepsi can would be cheaper to make because it requires less material, but right now we don't know by how much. Okay, so to figure that out, we're going to have to multiply by the price per square inch. So the Pepsi can, we're going to be doing 49.42 times 0.03. Okay, 1.4826, it's money, so round to the hundredths, $1.48. Okay, and then the Coke can was 51.05 times 0.03. And that, when we round to the hundredths place, should be $1.53. So let's find our difference. 153 minus 148 is going to be a 5-cent difference. Okay, so we can say the Pepsi can is cheaper by 5 cents. Okay, last page of the review sheet. Woo! Find the width of a rectangular prism that is 12 inches high, 27 inches long, and has a volume of 3,240 cubic inches. So we're talking volume. Volume of a rectangular prism is length times width times height. Let's substitute in what we know. We know the volume is 3,240. We know the length is 27. The width is what we're looking for, and the height is 12. So I put an X in for the width. So let's simplify there. 27 times 12 is 324, so that's 324x. Divide both sides by 324. Nice. X is equal to 10. So the width is 10 inches. Great. 19. Find the length of an edge of a cube with a surface area of 1,458 millimeters squared. Round to the nearest hundredth. Okay, so surface area of a cube is 6 times the side length squared, right? Because that side length squared is going to be the base. There's 6 of those congruent squares on the cube. So we know the surface area is 1,458 equals 6s squared. We'll divide both sides by 6. 1,458 divided by 6 is 243. Take the square root of both sides, and we'll round to the nearest hundredth. So square root of 243 rounded to the nearest hundredth is going to be 15.59. So 15.59 millimeters. Great. Excellent. So now 20, we've got the surface area of a cylinder can, a cylindrical can, I guess that should say, is 252 pi centimeters squared. If the radius of the top of the can is 7 centimeters, then find the height. Okay, so we're talking about cylinder, cylindrical can, let's say cylindrical. Surface area equals 2 pi r squared plus 2 pi r h. Okay, we know the surface area is 252 pi. We know the radius is 7. And we're going to solve for h. So we'll simplify. 7 squared is 49. 2 times 7 is 14, so we got 14 pi h. So that'll be 98 pi plus 14 pi h. Those are not like terms. We cannot combine them because one has h, one does not. So we'll subtract 98 pi from both sides. Okay, so 252 pi minus 98 pi is going to be 154 pi, which equals 14 pi h. And then to isolate the variable, we'll divide by the coefficient, 14 pi. Cancels on the left. 14 pi, I can see our pi's cancel there, so we're really just worried about 154 divided by 14, which is 11. So our height is 11 centimeters. Lovely. Okay. Last but not least, number 21. The height of a tuna can is about 1.25 inches, and the diameter of the can is about 3.25 inches. How much tuna is in one can? Round to the nearest tenth. Okay, so if it's talking about how much tuna is in the can, that's asking for volume, right? The can is a cylinder, so volume of a cylinder, pi r squared h. Okay, we're told that the height is 1.25, the diameter is 3.25, so the radius is going to be half of that. So 3.25 divided by 2, which is 1.625, and I'm not going to round that yet, I'll use it. So we've got pi times 1.625 squared times our height of 1.25, 1.625 squared, about 2.64, so it's going to be pi times 2.64 times 1.25, which will give us 3.3 pi. We'll multiply by pi and round to the nearest tenth, which will be 10.4 inches cubed of tuna. How much tuna is in a 4-pack? Sometimes you can get those cans of tuna in a 4-pack. I know I like to buy it that way, cheaper. So if we want to know how much is in a 4-pack, well, we'll just multiply by 4, right? So in a 4-pack should be 41.6. So 41.6 inches cubed of tuna, okay? And there you go. That's all she wrote.